Hi everyone, this is Lian Marie Barangco of BS ECE3C, and for ECE23 or Communications 2, we're going to discuss about our topics in Module 6, that is the coverage in our Performance Task 6. So the topics that we're going to discuss is the transition table, the state machine diagram, and determine the trellis diagram. So the three steps to determine the TCM, part 1 is to determine the values in transition table. Part 2 is to create a state machine diagram basing on the transition table. And lastly is we will transform our state machine diagram into trellis diagram. And this is our diagram. The rate is 1:3. This means that in every one output, we have three parities or outputs, and these are called the N1, the N2, and the N3. We have here two states, the S1 and the S0, which is the equivalent of M0 and M-1. And the operation that is being used in the given formulas in finding the values of the parities is going to be XOR operation. And in N1, basing on the arrows, we're going to find its value by input XOR S1, XOR S0. And in N2, it is going to be S1 XOR S0. And then in N3 is input XOR S0. Since we're going to do the shift register later, we need to know that this is a shift right. So how do we obtain the values in this transition table? So first we're given two states, and these two states can either have values of 0 or 1. And we will provide inputs of alternating 0 and 1s, and in the output side we have the N1, N2, and N3. And lastly, the obtained new or the next state basing by the process of the shift register. We have here the truth table of XOR, and for an example of determining the outputs, since the only given is the input and the current states, so this part are blank. So in finding the value of N1, first is we're going to XOR 0 and S1, so that would be 0 XOR 0, 0. And next is XOR 2 S0, so that would be as the output of 0. And for the N2 is S1 0 XOR 2 S0, which is also 0, the output would be 0. And in the N3, which the given would be the XOR of input and S0, which is both values of 0, will also lead us to the value of 0. And for determining the next state, if our input value is 0, we are going to move 0 to the next value of state. So that would be 0. The new value of S1 is 0. And in S0, we have here the value of 0. And we are going to move it to the right only to be disregarded. So their new value is 0 and 0, as seen in here in our table. And for another example, if we have, so 1 XOR 0 is equals to 1, and 1 XOR 0 is equals to 1. So the next value of N1 is 1. In N2 is S1 XOR S0. So S1, which is 0, XOR to 0 is still 0. And in N3, which is input XOR S0, that would be 1 XOR 0 um, equals to 1. So the value of entry is 1. And for the next state of our next value, we're going to base from the input side. So we are going to move 1 to the right, so S1 would be 1, and S0 will be 0. So the next state is 1 and 0. So that's how easy we're going to determine the values of our transition table. So after determining the values from the transition table, we can now draw our state machine diagram. And we have 4 states. That is 0, 0, 0, 1, 1, 0, and 1, 1. So we will base on the current state and to the next state. So first here we have here in if the input is 0 and the current state is 0, 0, the next state would be still 0, 0. So that means that from 0, 0 it will just go back to 0, 0. And our output for that is in N1 0, in N2 is 0, and in N3 is 0. So we are going to base this on our convolutional rate, which is 1:3. So if we have one input, we have 3 outputs. So the N1, N2, N3 here is 0, 0, 0. Next is from the state 0, 0, if our input is 1, it is going to be 1, 0. So from the current state 0, 0, the next state would be 1, 0. And since our input is 1 and our output is 1, 0, and 1. That's it. And next is if we have input of 0 and the current state is 0, 1, from 0, 1, the next state is 0, 0. So it is going to shift into 0, 0 from 0, 1. And the input is 0 and the output is 1, 1, 1. The next input is 1 and the current state is 0, 1, which leads to its next state that is 1, 0 with the input 1. The outputs would be 0, 1, 0. So from 0, 1, 2 and 0, the input of 1 and the output is 0, 1, 0. Next is from the input 0 of the current state 1, 0, it is going to be shifted in 0, 1. So from 1, 0 state, it is going to be in the next state 0, 1. Since the input is 0, the output would be 1, 1, 0. So we're going to put the rate in here. And next is if the output is 1 in our current state 1, 0, the next state is going to be in 1, 1. It's going to the arrow's direction is going to 1, 1. And the input is 1 and the output is 0, 1, 1. And for the last state, which is 1, 1, if the input is 0, the output is 0, 0, 1, and its next state is 0, 1. So the arrow is going in this direction. And lastly, if the input is 1 in the current state 1, 1, the output is going to be 1, 0, 0. And the next state is back to itself, which is the 1, 1. So that would be input 1, output 1, 0, 0. This is our state diagram that we determined using the transition table. Now in Trellis diagram, we will transform our state machine diagram and draw this trellis diagram. So basing on our first state or the current state, this will be the new state or the next state. From 0, 0, the next state is still 0, 0. Next is from 0, 0, the next state is 1, 0. Correct. And in 0, 1, its next state will go to 0, 0. And 0, 1's next state is 1, 0. And we are going to apply the same principle to the rest of the states. So that's how easy we can draw our trellis diagram. For summary, what is TCM? Trellis code modulation is a combination of coding and modulation. It is created by using convolutional code, which is discussed in this video. And the denominator or the output is known as parity symbols, and the higher the parity, it makes the system more immune to error. Shift register is the process of when the bits are being shifted to a particular direction. That's all. Thank you.